In a world where the boundaries of science and imagination blur, one question has captivated minds for centuries: is time travel just a fantastical dream, or could it be a scientific reality waiting to be unlocked? As we embark on this journey through the fabric of space-time, prepare to have your perceptions of reality challenged and your understanding of the universe expanded. Chapter 2: Einstein's Relativity: Time Isn't Constant. Our story begins with Albert Einstein, whose groundbreaking theory of relativity shattered our conventional understanding of time. Einstein proposed that time isn't a constant, ticking away uniformly for all observers. Instead, it's a flexible entity, intimately intertwined with space itself. This revelation laid the foundation for our modern understanding of time travel. But what does this mean in practical terms? NASA has confirmed the phenomenon of time dilation, where time actually slows down for objects moving at high speeds or in strong gravitational fields. This isn't science fiction, it's observable, measurable reality. Consider the Half-Alec-eating experiment of 1971. Atomic clocks placed on jet aircraft returned from their journey ever so slightly behind their earthbound counterparts. While the difference was minuscule, mere nanoseconds, it proved that time travel to the future is not only possible but happening all around us. Even the GPS satellites orbiting Earth must account for time dilation. Without adjusting for the faster passage of time at higher altitudes, our navigation systems would quickly become inaccurate. As NASA succinctly puts it, time and space are linked. The faster you move, the slower you experience time. But what about more dramatic forms of time travel? Could we one day step into a machine and emerge in the distant past or future? This is where our journey takes us into more speculative territory, guided by some of the most brilliant minds in theoretical physics. Chapter 3: Wormholes, Black Holes, and Cosmic Strings. Enter the concept of wormholes, or Einstein-Rosen bridges. These hypothetical tunnels through spacetime could potentially connect distant points in the universe or even different moments in time. While no one has observed a wormhole, they're consistent with Einstein's equations and have been the subject of serious scientific inquiry. Kip Thorne, the renowned physicist and scientific consultant for the film Interstellar, has extensively studied the possibility of traversable wormholes. His work suggests that while creating a wormhole would require exotic forms of matter with negative energy density, it's not necessarily impossible within the laws of physics. More recently, Pascal Coiron's research has explored models for stable wormholes that could theoretically remain open long enough for something or someone to pass through. While still highly speculative, these studies push the boundaries of our understanding and bring us closer to determining whether time travel via wormhole could ever be more than science fiction. But wormholes aren't the only theoretical gateway to time travel. Some physicists have proposed that rotating black holes or cosmic strings, hypothetical one-dimensional defects in spacetime, could also create conditions for time travel. These cosmic phenomena could potentially warp spacetime in ways that allow for closed time-like curves, paths through spacetime that return to their starting point in both space and time. Chapter 4: Quantum Mechanics and Time Loops. As we delve deeper into the realm of the possible, we encounter the strange and counterintuitive world of quantum mechanics. Here, particles can exist in multiple states simultaneously, and cause and effect become blurred. Some interpretations of quantum theory suggest that time itself may not be as linear as we perceive it. Consider time crystals, a recently discovered state of matter that appears to break time translation symmetry. These structures repeat in time just as conventional crystals repeat in space, challenging our understanding of the nature of time itself. The concept of quantum entanglement, where particles can be instantaneously connected regardless of distance, has led some physicists to speculate about the possibility of quantum time travel. David Deutsch's work on closed time-like curves in quantum systems suggests that paradoxes typically associated with time travel might be resolved at the quantum level. Chapter 5: Paradoxes, Ethics, and Multiverse Theory. But with the possibility of time travel comes a host of paradoxes and ethical quandaries. The grandfather paradox is perhaps the most famous. What would happen if you traveled back in time and prevented your own grandparents from meeting? Would you cease to exist, or would your actions simply create a new timeline? This leads us to the intriguing concept of the multiverse theory. Some physicists propose that every time travel event could spawn a new timeline or parallel universe, potentially resolving paradoxes by allowing multiple versions of reality to coexist. The late Stephen Hawking once quipped, "If time travel were possible, we'd already be visited by tourists from the future." While this observation is often cited as an argument against time travel, it doesn't account for the possibility of branching timelines or the potential limitations of time travel technology. Chapter 6: Real Experiments and What's Next. As we look to the future, real-world experiments continue to push the boundaries of our understanding of time. The development of increasingly precise atomic clocks allows us to measure time dilation with unprecedented accuracy. Astronauts on the International Space Station experience time dilation effects that, while small, are measurable over long-duration missions. Quantum computing, still in its infancy, holds the potential to revolutionize our ability to simulate and understand complex spacetime phenomena. As our technological capabilities advance, we may find new ways to manipulate the fabric of reality itself. The quest to unlock the secrets of time travel is more than just a scientific endeavor. It's a journey that challenges our fundamental understanding of the universe and our place within it. While we may not be stepping into time machines anytime soon, the pursuit of this knowledge is expanding the frontiers of physics and pushing the limits of human ingenuity. As we conclude our exploration of time travel, remember that the line between the impossible and the merely improbable has shifted many times throughout history. What seems like fantasy today may be the physics of tomorrow. The truth about time travel isn't a simple yes or no, it's an ongoing story of discovery, innovation, and the relentless human drive to understand the deepest mysteries of our universe. Time travel may not be fiction, it may be physics waiting to be unlocked. And as we continue to probe the nature of time itself, who knows what incredible discoveries await us in the future or perhaps even in the past. Thank you for watching.